Assalamu alaikum. I hope that you all are doing well. What we are doing is very quick recap of chapter number 1, topics that you have to study. And this is a very important chapter. First thing that you need to know in this chapter, data representation, is the number system. And the 3 number system that you need to know are binary number system, hexadecimal number system, and denary number system. Ye pata ho ke what are the pros, what are the features of all these 3? Like binary is a base 2 number system. It has 2 values, 0 and 1. Denary is a base 10 number system, which is understood by the humans, while binary is understood by the computer. और उसमें जो total values होती हैं that are from 0 to 9. That makes it denary or base 10 number system. After that, you need to know the hexadecimal, which is base 16, and it has values from 0 to 9, and then the values 10 is represented by 10, 11, 12, 13, 14, and 15 are represented by the letters A, B, C, D, E, F, respectively. The very important thing that you need to know is how to convert, and for that, the best thing that you need to remember is the byte values, which are 2 power 0, 2 power 1, 2 power 2, 2 power 3, 4, 5, and 6, and then 7. The last value is 2 power 7 for a byte. And you need to know the values 1, 2, 4, 8, 16, 32, 64, 128. These should be very much embedded in your memories. आपने इसमें किसी किस्म की गलती नहीं करनी है. The bits that are turned on, that are ones, you simply remember and to add those values which have the bit value 1 and ignore the rest. And what I suggest you is you can simply cut the value that are containing a 0, and you just simply add all those values that have the value of 1. And in this manner, you'll be able, like for example, in this question, you can see the bits that is representing 2 is turned on, then representing 4 is turned on, then 8 is turned on, then 32, then 64, and 128. So in order to find out, what you will be doing is you'll be adding 128, 64, 32, 8, 4, and 2, and whatever you get is going to be the equivalent denary value. Same is the situation with your denary to binary conversion. This is your byte, which has the value from 1 to 4, 16, 32, 64, 128. So if you are asked to convert a denary value to its equivalent binary value, what you will do is you will simply do one thing, and that is you will be turning on, or you'll be putting 1 in those values that add up to find out your value, to find out your total sum. Like for example, अगर मुझे कहा गया कि 122 42 की binary बनाइए, so what I will do is I will simply put 1 here, 128, and then I will subtract from 142 the value 128, and whatever is the result, I'll put all those bits turned on that are going to give me this value of 14, because 142 minus 128 is 14, and I'll find out the binary for 14 very simply, and that will make my conversion faster, quicker, and you can score full marks easily in these two conversions. Although we have the second method of division as well, but I suggest you that you learn the byte method, that is 1 to 4, 16, 32, 64, 128. Sometimes you can get a question कि आपको 12 bits में represent करना है, no worries at all. You move ahead and you can see that after that you will get 1 to 56, 5 and 12, 1024 and 2048. Sometimes it can even give you a value that is coming in 16 bits, no problem. What you can do further is just remember the multiples of 2 are supposed to be taken into account. याद नहीं है, कोई मसला नहीं है, बिल्कुल परेशान नहीं होना. अगर सवाल आता है तो you will simply multiply each value by 2, each older value by 2 to get the new value. Like you can see, I didn't remember 256 is going to be the next value. I simply multiplied 128 by 2 and I got 256. And then I multiplied 56 by 2 to get 512. In this manner, you can simply get all the values, no matter how many bits are there. Magar, agar aap pas 12 bits ki value hai, so you need to remember that you have to complete your answer in 12-bit pattern, and you are not supposed to leave a single bit blank. That will make your answer complete. That will actually make you get full marks. Now, as far as hexadecimal system is concerned, for that you need to remember the nibble, the 4 bits, and the simple thing that you need to remember is this table. I suggest you that even in your paper you write down that A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15, so that you're not going to make a mistake at all. Well, it's okay, perfectly okay, that you write it down on one side of your paper, of the page, and then carry on with your work. One caution that you need to remember is when you are asked to convert from binary to hexadecimal or vice versa, but what you need to remember is the nibble. Like for example, you can see here, example is given to you, and what you will be doing is, in order to convert a binary value to hexadecimal, you will make a combination of 4 bits pattern. But one thing is, you have to start from the right hand side, as I had been telling you repeatedly in the classes. So you'll make a pattern of 4 bits each, starting from the right hand side, from the LSB, and then you will make it look like this. And then you will write down the equivalent value, since you know that 1011 is equal to 11, and that is making it B. So that is why you will write down B here. You will not write down 11. Be very cautious. अगर आपने वहाँ 11 लिख दिया, तो that it is possible that you may land into an answer that is 1, 1, 1, 4, and 1. So be very cautious that you write down the equivalent then hexadecimal value immediately. One thing that you can see here, in this case, if you had started from the left-hand side, then your answer will be completely wrong. And that is why I suggest you that whenever you get a conversion from binary to hexadecimal, always start making the patterns from the right-hand side, making 4 bits pattern each. 4 bits are going to be combined together to make one value, and then you'll move ahead with the next pattern, then move ahead with the next pattern, and then in this manner you will end up with 3 groups that are complete, and the last group is incomplete because it has 2 bits only. No worries, you'll put up zeros, and these are your non-significant zeros. So you're going to put them here, and then that will result in your complete answer. As you can see here, although it has no impact on the answer, but still it is always suggested that you pad up with the zeros, the non-significant zeros. Now, moving on to the next conversion, very simple one. What you are given is, you are given a hexadecimal value. And remember, hexadecimal value may contain a value from 0 to 9 as well, as I told you in the beginning. So what you will get is, you will simply recall the table that you have learned. And if you don't remember, still no worries. You simply write down 1, 2, 4, 8 on one side. Because actually a nibble has 1, 2, 4, 8 values, and then you will find out the value, equivalent binary value for all the hexadecimal values very easily, and you will get the final answer without any problem at all. Moving on to the next conversion, when you are asked to convert from hexadecimal to denary or denary to hexadecimal, from hexadecimal to denary is very simple. You will be actually multiplying it by the powers of 16, 16 power 0, 16 power 1, 16 power 2. That is equal to 1, 16, and 256. And what you will be doing then is, you will be multiplying 256 by 4, you will be multiplying 16 by 5, and you will be multiplying 1 by 10. And then you will be adding up all the results, and whatever you obtain is going to be written in the end as your final answer. On the contrary, if you are asked to convert a the denary value to hexadecimal, simply remember that you have to work with the table of 16, and then you will write down the remainder. But one caution is, if you get the remainder as 10, 11, 12, 13, 14, or 15, you will simply write down the equivalent hex value. Do not forget to write down, otherwise I've seen students landing up into the wrong answer, that they write down 7134. And but one more caution is, you always start from below to top you go, and then you write down the answers. Many times the students do this mistake, that they have done the division correctly, but when it comes to answering, they're putting the answer in the final place, they write down 4137 or maybe 4D7. That is going to be wrong. So be very cautious. Inshallah, you'll be successful in this conversion topic very easily, inshallah. After that, what you need to know is a very simple topic, use of hexadecimal. You need to know you can get a question that deals with the use of hexadecimal, very simple topic. But one caution is, if they give you one example and they ask you about the other examples, do not forget to read the question thoroughly and ignore that example and work with the rest. Like, for example, if they have written that one example of hexadecimal or one use of hexadecimal is MAC address, so do not mention MAC address in your answer. One thing more is, it's IPv6, that is the use, not IPv4. So do not mention IPv4 as their answer, or do not mention IP as the answer. The IP address is not going to give you any mark at all, because that is the wrong answer. So be very cautious about this, and then you can get marks very easily. Error code is simple. What you need to know in this one is MAC address, very simple. Although you can study this topic under the heading of like network devices as well in chapter number 3. But right now you need to know what is the MAC address, what is the format of the MAC address. As you can see, the format is NN, 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 DD, DD, DD. It's a 48 bits MAC address, or it can be a 64-bit MAC address also. It can be represented by putting hyphen in between, or by putting a colon sign in between. And then what you need to know is the two types. What is it denoting? The first set of N is denoting the manufacturer, and the second set is representing your serial number. So this one, again, you need to remember that can come in your paper, and you can get very easy marks very easily if you remember these simple things. Now, moving further, IPv6, as you can see, you can even get a question that deals with the difference between IPv4 and IPv6, which I'll inshallah cover later as well. And you can see here, it's the representation of it's a representation that comes in 128 bits. IPv6, it's separated by a colon sign, and it's basically a 16-bit chunk that is also written here. After that, you can see hypertext markup language. What you need to know is you can even get a question that deals with comparing HTML markup language with your normal programming language. So this is what you can remember. You can have learned it in the class. I've been asking you repeatedly to remember this, that actually HTML is not similar to your programming language. It is a markup language that is meant to be used in the processing, definition, presentation of your text. Like, for example, the color of the text. For example, if you set the color of the text in your web page, that is going to be treated as a markup language. You can't add two numbers to find out the result. And that is why it is called a markup language and not a programming language. Along with that, what you need to remember is the tags. What are tags? Basically, the instructions that are there used in HTML to give some task to be done in a web page. And there are different tags, but what you can see here is, since you people have already done it, so you need you need to recall the tags are written in the angular brackets, and sometimes we do have a standalone tag, and normally it's the container tag. So this is something that you need to remember. And after that, you need to actually go with the color combinations, and that is also color codes are either represented by putting the word itself, which is the key, normally the main colors that are represented. And one more method is you can represent the colors with the help of hash, and then you can write down the three sets, which is the first set is denoting the red color, the second set is denoting the green color, the third set is denoting your blue colors, RGB combination. As you can see that you can when you can be asked sometimes to even add up two colors and find out the result. It's very simple calculation you can do, and you can find out. Like, for example, if I say, okay, I was asked to add the red color and the green color. So what I will do is I will add up these two colors, okay? And what the final answer will be, I'll start from this side. 0, 0 will be added to get a 0. 0, 0, 0 will be added to get a 0. 0, F will be added to get an F. Then again F, then again F, and then again F. So my final answer will be, do not forget to mention hash, and then hash FF, FF00. That will be combining the red color and the green color, and this is how you can get a question in your paper as well. After that, addition of binary. Again, you need to know the concept of carry, sum, and overflow. Like, for example, we have been doing this. So you can see if I am given 3 values, or if I'm given 2 values to be added, the simple principle is 0 plus 0 is a 0, carry 0, and sum 0. 0 plus 1 is a carry 0, and sum is a 1. 1 plus 0 is 0, carry, and 1 is your result. And 1 plus 1 is 1 carry, and 0 is your sum value. And similarly, if you have 1 plus 1 plus 1, 3 ones are here. So what you will have is you will have 1 carry and 1 sum. So this is something that you can remember and you can practice, but do practice. And along with that, you need to know the concept of an overflow. Like, for example, if I'm adding 2 binary values, which are coming in 8 bits, but I am getting the final answer of addition in 9 bits, then definitely that will result in a situation that is called overflow. So you need to actually remember this concept of overflow. Okay, if I'm adding 2 binary numbers and the result is coming in the 9th bit, then that 9th bit is treated as an overflow situation. So this is something that you need to remember. The same thing is mentioned here. Addition has generated a 9th bit, the 8 bits. This is going to give you the wrong answer, because definitely the 8-bit combination cannot be exceeded in norm, and that may result in your overflow error. So you need to be cautious on how to answer. And please remember, if it's a 3-mark question, if it's a 2-mark question, then you need to see that how many marks, how many points you will write down to get the full marks. Then we have the logical binary shift, the right shift and the left shift, and you can see that what is the impact. Sometimes you can even be asked कि जी हमने left shift किया, हमने right shift किया, impact क्या आएगा, you are asked to comment on what is happening. So you can see that for yourself, even by doing it, you can see for yourself that it's with each left shift, it means it is multiplying by 2. One shift means multiplying by 2, two shift means multiplying by 4, three shift means multiplying by 8. In this manner, you can see for yourself that what happens if the values are shifted to the left or to the right. Same case goes for right shifting. It results in division. One shift means division by 2, two shift means division by 4, division by 8. If it's three shift in this manner, you can go ahead. Now you need to remember that whatever shifting has been done, the empty spaces will always be containing a 0. Please do not think that the value that has been shifted will be moving to the empty locations. That will always be resulting in a 0 padding for your location that are empty. इसके अलावा what you need to remember is it may happen that you are performing the shifting and it may result in the byte that is not giving you the correct answer. In some situations, you can see for yourself. Like for example, if I say this is my question that is given to me, 000100101. If I'm asked to perform 3 shifts till that point, till 3 shifts to the left, till that point it will give me the correct answer as far as the multiplication process is concerned. But if I actually perform before shifting, then you can see for yourself, you can even practice it yourself, and you can see for yourself that that results in your incorrect answer, because definitely in 4 shifting, what happens is this one is lost, and the loss of this one may not give you the correct answer as far as multiplication is concerned. Now, this is something that you need to remember, and I hope that you will be able to score easily in this topic. Now, moving on to the next topic that you have to study is 2's complement. Very, very important. One thing that you need to remember is in 2's complement, what you need to do is, if it's a positive number, there is no impact. Like for example, if I say +6. So if I am finding out the normal binary, or if I'm finding out the value for +6, the binary will remain same. The only change is that whenever we are asked to perform 2's complement, this bit, which is MSB, becomes the sign bit. And this is going to hold a value of 1 in case your number is a negative number. And this holds a value of 0 in case it is a positive number. So this bit is no more used for storing the data. This bit is now used to store the 0 or a 1, indicating the value is a positive number or a negative number. Now, it means that the capacity of the byte has also changed whenever we worked on 2's complement. Now, the data that the value is going to be from -120 to 127. So this is something that you need to remember. The MSB becomes the sign bit, and this MSB will no more be holding the data. This MSB will be now meant to store the value of 0 or a 1, indicating it's a negative number or it's a positive number. And now you can see for yourself, normal is 4-bit binary enable. Normally it is 1248, but once it comes to the 2's complement situation, this will no more be meant to store 8, it will be -8. And definitely it means it is -8 plus 2 that will be resulting in -6. So I hope that it's very much clear. Now, moving on to the method that we have learned and we have to actually apply. Simple method, very simple. What you are asked to do, again mentioned here, writing positive number in 2's complement, it's the same as you do, but the only change is the capacity changes. Now you can store the data till 127. While if I talk about the norm is, when I talk about the byte, the capacity of the byte is 255. But when it comes to 2's complement, capacity changes to 127. And now moving on to this one, I have the question that is given to me, and you can see for yourself, it is, if I'm asked to convert, to find out the value for 39, it's going to be the same as I normally work with 39. But the moment I'm asked to work on a negative value, the change is, just remember what you will do. The norm is, this is the simple thing that you can do definitely, but 2's complement says what? Aapne karna kya uske andar? This is the norm, as I told you. So you will fill it with -128, whatever is left out, you will simply find out the value and you'll be able to find out the result. But as far as 2's complement method is concerned, this method one is very easy, as we have been talking about, that you are going to work with 67 is the same, but -67 will be resulting in something differently. It will be -128 plus 32 plus 16 plus 8 plus 4 plus 1 will give you of the value of -67. Now, as far as 2's complement method is concerned, what you do is you will first of all find out the value of 67, ignoring the negative sign. Like right now, you will assume that it's no more minus 67 is 67, and you will get the value of the boundary value of 67. Then you will actually do the you will invert. You will perform the values to be inverted. All the ones become 0 and all the zeros become 1. So you can see 67 is this one. And what you did was you have inverted all the values and you have found the answer as 1 0 double 1 double 1 double 1 double 0. And then you are going to add a 1 to this answer, and what you obtain as a final answer is your value for minus 67. And you can see for yourself, either you are doing it this way or you are doing it this way. In both scenarios, we're getting the same answer. But if you're asked to perform the 2's complement method for positive, you will simply find out the answers but the same method as you have been applying. The only change is you'll mention minus 128 there. And as far as this method is concerned, you will please remember that this is what you will follow. Each step carries marks. You will first of all simply find out the answer for the normal, and then you will invert, and then you will add a 1, and what you get as a final answer of your 2's complement value. A very easy thing to score, not a difficult thing. Okay, now as far as character sets is concerned, what you need to know is the difference between ASCII and Unicode and ASCII code. And as we have been talking about in the classes, ASCII code is one byte, or maybe you can say it is going to store the lesser number of values, and Unicode is going to store more data. More values, more characters are being stored there because it can store even the Chinese characters. Another difference is Unicode is storing the data in 4 bytes as compared to ASCII code or extant ASCII that's storing the data, the occupying 1 byte to store the data. And in reality, ASCII is using 7 bits, not even 8 bits. Extant ASCII is using 8 bits. So you can even mention 1 byte or 4 bytes. That is also going to give you the correct answer. So you can be asked in the paper about the difference between ASCII and Uni. You can simply write down the 2 differences, the capacity and the type of data that is being stored. And in this manner, you can very easily score 2 out of 2 if they are asking you to mention 2 differences. If they really want, you can simply go ahead and talk about that what kind of data is being stored. ASCII code stores the normal data, while extant ASCII is going to store more data as compared to the normal. The next topic that you have to study in chapter number 1 is your representation of sound. And in this topic, you need to actually remember a few definitions that are, and there is a chance that you can get those definitions in your paper. And these are sampling resolution and sampling rate. As you can see, the number of bits per sample is known as sampling resolution. And the same is also, we can say, is also known as the bit depth. Sampling rate is the number of sound samples taken per second, and it is measured in hertz. And this is going to give you the correct answer. This will definitely give you 1 out of 1 or 2 out of 2, depending upon your answer required. One more thing that you need to remember is the advantage of using larger sampling resolution. Very simple thing. You can see for yourself the benefits and the drawbacks are very simple. Producing large file sizes takes longer time to transmit, requires greater processing power are the drawbacks of this larger file samples, the sampling resolution. And on the contrary, the benefits are larger dynamic range, better sound quality, and less sound distortion. So which are the norms? Very easy to remember as far as this topic is concerned. The next one that I need to remember is representation of bitmap images. And in this, you need to know the term pixelation. And you need to actually work on the image resolution, the term as well. I hope that you remember the term resolution, image resolution. And after that, the units. Very important that you need to know is 1 kilobyte and 1 kibibyte. 1 kilobyte is 1000. And you can see the kilobyte and then megabyte and then gigabyte and then terabyte, and then petabyte and then exabyte. They all are multiples of 1000. So even if you don't remember the values, what you need to see is 1 KB is 1000. And 1000 into 1000 will be megabyte, then 1000 into 1000 into 1000 will be gigabyte, and then terabyte is 1000 into 1000 into 1000 into 1000 4 times. And in this manner, you can remember the values very easily. Kilo, mega, giga, tera, peta, and beta, and exabyte. Now, moving further, we do have the next memory unit, that is IEC. And that is something that you need to remember as far as your exam paper is concerned. If they ask you about the KB, you need to mention the value of 1024. And then maybe will be 1048576. If you don't remember, no worries. You can simply write down 1024 into 1024. Perfectly okay to write it down that way. And then gigabyte is 1024 into 1024 into 1024. No need to again remember or rote learn this value at all, please. Then terabyte is 2 to the power 40 bytes. So you can simply write down 1024 into 1024 into 1024 into 1024 or 1024 to the power 4. And that will again give you 2, 3, and then 4. 1024 to the power 4, 1024 to the power 5, 1024 to the power 6. In this manner, can remember it's babybyte and then exabyte. In this manner, all the values are supposed to be worked upon. Okay, moving further, calculation of file sizes, very, very important. And the simple thing that you need to remember is this formula, image resolution in pixels and the color depth. And these two values will be multiplied together. And then you can see the values in bits. And then if they ask you to convert it into bytes, you will divide it by 8. They ask you to convert it into kilobytes, and you will divide it by 1024. The answer that you have obtained right now, and if they say that maybe byte, in this manner, you will divide it by 1024 twice to the power 1024 square, and in this manner, you will keep on finding out the answer. And remember, each stage carries marks. Each step carries marks, and I suggest you that rather than forming the multiplication, you go with the division method, and in this manner, you'll be able to score marks easily. And the questions, please do solve them. That will benefit you a lot from the past papers. A few I've shared with you, and I want you people to please do them for your own benefit. Along with that, you can sometimes be asked about the size of a sound file, and you can see for yourself the formula is very simple. Sample rate in hertz, multiply sampling resolution in bits, and then length of the sample in seconds. Remember, the unit is in seconds. So if your question deals with minutes, then you have to convert this minute into seconds to find out the final answer in seconds, and then you will multiply all the values together to find out the value for the mono sound file. And if it's a stereo, then you have to multiply the result by 2 because stereo is dealing with multiply by 2 situation. And you can see the examples as discussed in the class. You can find out the questions from the past papers. You can even do the activities. And then definitely you will be able to have a good grip on this topic as well. Last but not the least, data compression. You need to know what compression is, means reducing the size of the file. Along with that, you need to know what are the actual reasons of compression to save the storage space on devices, to reduce the time taken to stream a music or a video file, to reduce the time taken to upload or download or transfer files across the network. And these are the basic advantages. I suggest you that you actually learn the two most important ones, which are dealing with storage space is being saved, and secondly, it is easier or it is going to take lesser time to upload or download or transfer the files across the network. That will actually give you full marks definitely. But this is my suggestion. Now moving further, the two formats that you need to remember, lossy and lossless, very simple, very easy. In lossy, it is going to result in the loss of data. You cannot reconstruct the file back. And it is going to eliminate unnecessary data and then you cannot reconstruct. And what are the examples you can see? Normally, we apply lossy on a sound file or an image file. And for that, you can see for yourself that we have actually learned the sound file is going to be your MP3 or MP4, and the image files are your JPEG files. So what happens is, you can see for yourself that when it comes to the removing sound, what is being done is removal of sounds outside the human ear range. And if two sounds are played together, then the louder sound is being heard by the ear, the softer sound is eliminated, and this is called perceptual music shaping. This term you need to remember. And MP4 is basically your video files, and you can see that this is also a format that is a lossy file format. As far as JPEG is concerned, what is it actually? It's a lossy file format that is applied on, again, the pictures, the images. And you can see human eyes don't detect difference in shades. In color shades, they are being eliminated. Similarly, by separating pixel colors from brightness, images can be split into 8 by 8 pixel block, and that will also result in discarding a few information, and that also results in a file size being reduced, and that is a lossy file format. On the contrary, lossless is applied on your important documents. Loss is applied on your spreadsheet. Lossless is applied on your program files, because they should be exactly same when they are being received by the receiver. If they are undergoing lossy, that will be a disaster. So that is why you can see, and along with that, you need to remember RLE, run length encoding. There is a method that is a form of lossless compression or reversible file compression. It reduces the size of string of adjacent and identical data. And in that, what you need to know is applying RLE on text data, the format that we have learned. Whatever is available repeatedly is being stored as a character. That, for example, letter A, which is having the ASCII value of 97, is appearing 5 times. So that will be 5 times 97 is appearing. Similarly, same goes for 4 times 98, which is the value for B. Same case goes for the value of C is appearing twice. So that is why it is written 299. And then D, which is 100, is repeated five times. That will result in reducing the storage capacity of your file, of your compressed file. And that is also a good method that is applied on your string data. Another one is if string data is composed of some characters that are repeated and some characters that are non-repeated. So in this case, what is done is the use of a flag. So you can see for yourself, the repeated characters are included in the value 255 as a flag. And on the contrary, the ones that are non-repeating are written as such. Like for example, CD, CD, CD are appearing separately without a combination. So they are written as 9900, 9900, 9900, and all on the contrary, all others are written with the flag value. Similarly, you can apply RLE on images, but something that is a little, you can say, which we never studied before. But now we are learning that we can apply this RLE runtime encoding on images as well. As you can see, the images are stored in this manner. So you can see for yourself, the white characters are represented by a 1, and the black characters are represented by a 0. And then they are compressed in this manner that, for example, if there are 8 and then 9 white characters, they are represented as 9. 1, because 1 is representing the value of white color. Similarly, we have also learned how is colored image, how are colored images and also undergoing RLE compression method. So you can see for yourself something similar to the same that we have learned right now, but only the change is now you will represent the colors also, because the colors, again, the whole table will be given to you. And what you need to know is you will simply write down the values. Like for example, the first line contains two black boxes, and then 4 green boxes, and then 2 black boxes, and then 1 black box here. So what you can see here, 2 times the value of black, that is 0, 0, 0. That is what you can see here. It says 2 times 0, 0, 0. Then 4 times green in color is 4 times 4 is written here, and then green color is 0 to 55, 0. That is written here. Then 2 and then 1, 3. So you can see for yourself 3 times black color is here. That's why it's 3, 0, 0, 0, 0. In this manner, you can see the whole file is compressed, and definitely as compared to the original file being sent, RLE undergoes compression that results in reducing the size of the file. So in this manner, you can remember, very quick recap is being done for you, and you can remember all these things, and that will benefit you in preparing this topic. Then do the past paper practice questions and the exam style questions, and inshallah you will be doing well from this topic. Okay, now thank you very much. Allah Hafiz for the time being.